Welcome to CSAI Think Tinker Learn. Today, we were diving into one of the most critical skills for a backend architect, data partitioning at scale. This is part of our System Design Essential series, designed to give you a solid mental model of complex architectural topics quickly and concisely. Don't forget to check out our companion site, the link is in the description. These videos are high level overviews. If you want anything related into this particular topic, any deep dive, uh, please let us know in the comments and we'll make sure that we make a video on that. Now, let's come back to this video. Let's break this down. Every scale story starts with a monolith, but a monolith is doomed to fail. You eventually hit the four walls. Storage maxes out your disk capacity. CPU is overwhelmed by concurrent read I/O. Write triggers serial bottlenecks due to lock contention, and physical distance creates unacceptable latency. When vertical scaling, which is buying a bigger box, hits its economic ceiling, you must scale horizontally. You distribute the load, but the trick is ensuring you actually balance it. The core mechanism here is horizontal sharding. We introduce a shard router that inspects the incoming query's shard key, calculates the destination mathematically, and forwards the payload. However, sharding is a high stake decision. A meticulously chosen key is a dependency for success. A poorly chosen one turns one shard into a glowing red hotspot while others just sit idle. You might have distributed the data, but you failed to distribute the work. There are three primary routing strategies. Range-based is best for time series data and sequential lookup, but risky due to temporal hotspots. Hash-based is the gold standard for even distribution of uniform data, though resharding carries a heavy migration penalty. Directory-based gives you the most granular control, perfect for isolating whale tenants, but it requires a manual lookup table. You must choose based on your specific access patterns. The breakthrough for distributed systems was consistent hashing. We map both nodes and keys onto a logical 2 raised to power 32 ring. Keys are assigned to the first node found moving clockwise. The genius here is that adding a new node only impacts the immediate arc behind it. Without consistent hashing, changing your shard count requires a catastrophic 99% data migration. With it, you only move a small fraction of your data. Before you can fix a hotspot, you must diagnose its type. There are three enemies: temporal, sequential timestamp crashing into the newest node. Number two is popularity. Driven by Zipf's law, there is a viral celebrity record receives a massive block of reads. Third is structural. A biased shard key, like sharding a country code where one node is permanently oversized. You cannot solve the problem until you identify which one you are fighting. Mitigation one targets structural imbalance through virtual nodes. We assign each physical shard 100 to 200 virtual or phantom position on the ring. This averages out the hash distribution, ensuring no physical node owns a disproportionately large arc. The failure point: too many virtual nodes can consume excess router memory and overcomplicate your topology. It's a balancing act. Mitigation 2 targets temporal writes via key salting. We append a random suffix to a highly active sequential key. This forcefully scatters a massive write spike across the entire cluster. However, there is a fan-out penalty. To read that data back, the application must query all salted version across multiple nodes and merge them in memory. Use this technique surgically, only for your heaviest write-heavy hotspots. Mitigation 3 and 4 handle popularity reads. We isolate the top 1% of heavily accessed whale keys into explicitly over-provisioned shards. More importantly, we place a cache firewall like a Redis cluster in front. This absorbs 99.9% of the read spikes before they even touch the database. Just watch out for the cache stampede. If a celebrity key expires, thousands of simultaneous queries can still crash the origin. Mitigation 5 is the classic read replica. We clone the data, letting the primary node handle the ACID writes while the router uses round robin or least connection algorithms to distribute queries across read-only copies. The critical failure point here is replication lag. If your replica falls behind the primary, users will see stale data. If you need strict read your writes consistency, you must route those specific reads back to the primary. The blueprint for a perfect shard key rests on four pillars. High cardinality, you need millions of distinct values. Uniform distribution, values must spread evenly. Stability, never shard by a value that updates, like an email address. And query locality, minimize cross shard scatter gather operations. If your shard key fails any of these, your cluster will eventually lean. An advanced pattern is a composite key. When one column can't satisfy both locality and distribution, we combine them. The partition key determines which physical shard the data lives on to satisfy query locality. The clustering key determines the sort order physically on the disk within that shard. This allows you to isolate queries to a single node while maintaining highly efficient sorted retrieval. Let's look at the real world case study. Discord message storage. They originally sharded message by channel ID in MongoDB. This gave them perfect query locality, but popular public channel became brutal read-write hotspot that melted nodes. Their fix was moving to Cassandra using a composite key of channel ID and message ID plus consistent hashing. This balanced the load while keeping messages for a channel co-located enough for performance. As an architect, you cannot run these systems blind. Monitor your operations telemetry. Watch your shard size ratio. If your max to min ratio is over 2x, you have structural skew. Check your P95 latency. A 10x peer average means an active hotspot. And never forget the golden rule. Never use monotonically increasing keys for pure range writes. You will create a perpetual hot tail partition that will kill your performance. When you are at the whiteboard, follow the 6-step protocol. Identify query filters, measure skew, pick your primary dimension, and augment with secondary techniques. Sketch the math and plan the rebalance. Now, a question for you. In your current system, what is your primary sharding dimension? And have you ever had to deal with a hot partition during a traffic spike? Let us know in the comments. If this teardown was helpful, please like, share, and subscribe to CSAI Think Tinker Learn. Visit the site for more essentials. See you in the next one.